Is my screen visible? Okay. So, so in this session, we will be meeting every Friday at 6 to 8. So, in this session, we will be discussing what are your doubts and solve some questions of previous year. And yes, so we'll solve some previous year questions and we will clarify your doubts. And so, if you have any doubt, you can start asking them. Like any particular section, we can rediscuss something overally, and then we can move to solving the previous year question. Uh, Whoever is if someone want to ask any doubt or something, they can unmute and ask. It will be better. You can unmute, right? Everyone can unmute, right? Okay, so Shashi said, can you change timing? Actually, the thing is that before this course has begun, we wanted to we asked that what is the convenient timing for me. So it's it is assigned 6 to 8. So I don't think I can change. I will ask the authorities who schedule this. So I'll ask them to change. If they can change, then it's fine for me. But it's not in my hand, I guess. I'll just ask them if they are agreeing to change the slot. If they will, I will change the slot accordingly. Any other chat? So okay. So we can solve some previous year questions. I guess. Okay, there is chat. We can solve the questions of last year. Okay. So let's just discuss about like what has been discussed in the course. Uh, so okay, so we can start with like so someone asked like to talk about the wavelets. So what I so I'll just try to draw a picture of what this course is trying to teach here. The first thing is that we are all familiar with the basics of deep learning, like not basics of deep learning. I can say so everyone is like well aware of that this deep learning. Uh, basically, what is happening is that so the course name is Deep Learning for Visual Computing, but there are some stuffs that has been discussed in the lecture one, which is not the part of deep learning, but it's a basic image processing. So suppose it's the image of a person. Okay. And so what earlier method did, so what they did is that, so they wanted to see what are the features and what are the characteristics or what are the properties of a image that is shown to us. And they try to evaluate those properties, and they try to quantify those properties, and based on the property of a image, they try to classify it, or they try to further gain inference out of the image. So there are like a couple of different methods they have proposed. Like so in the first class, they said that uh, so there are many way to find textures in the image. So some of them are like structural, and some of them are like statistical. So basically, in the structural, uh, uh, so we have this list. In the structural, we have. Give me one second. I have that material. Where is it? I have a query regarding school and not deep learning and join two courses related to deep learning. So I am now start with the courses and since more focused towards visual computing. Yes. See. So if we see now, like so basically, so deep learning is the technique. Okay. And um, computer deep learning for visual computing is using that technique for image and video data itself. So deep learning is the core technique, and this deep learning for visual computing course is basically using deep learning for visual computing for images and videos. So if you want to like go very deep inside the course, you should first definitely take the deep learning course, and get a clear idea of that. And so basically, deep learning is a technique. So to apply that technique, you need some data, right? So that data can be text, that data can be image, data can be video, or the data can be also audio. So basically, if the data set is image, so it is this course, like we're still looking at deep learning techniques that is used to evaluate certain images and videos. But the thing is that in the deep learning course, to test a algorithm or test a technique, the basic data set we will use is images. It's not like that you are learning about a deep learning algorithm, and suddenly the teacher will start talking about audios or something. So those are there, but the major things will be focused on the images. And it will be better like to go through the deep learning course once and come to this course. uh, but the beauty is that this course also covers some part of the deep learning, so you don't have to so if you want to gain a very deep understanding of the thing, you can definitely go and check out the uh, uh, deep learning course and come to this. If you still want to learn just this course, like just as a just want to use this as a tool, so there is some deep learning part that is there in the week two, I guess. Week two, I guess. In the week two, there is a brief overview of deep learning that you can go through and then come back to the course and see if it is. I mean, you can. So all those deep learning are covered, which will required for this course to go on. So that's why you're good to go if you just take this course. If you have taken the deep learning course, it's fine. I'll go through the class session and share the non-classing schedule in your class forum by Sunday. I'll request you to ask. Okay. Okay. So, anything else from the um, kind of admin side? I have one more query request that can we discuss like completing a project related to the syllabus covering in this course, as I am more interested in practical understanding of the subject area. We can do a project, but I guess like there are like 1200 students in this course. So given that not all people will be joining in the live session, carrying out a project would be good, but like the instruction in our like the instruction that is given to us is that we will just come and clarify the doubts regarding the course and not doubt like some if some concept is unclear, we can clarify that and we can solve some previous year questions related to the course. It's like a tutorial, like if you see, so there will be course where the professor will be talking about all the overall idea and we all be talking about like taking that idea and solving some problem associated with it. If you look at the project, so project will need guidance, I guess, uh, because like I cannot suggest to just suggest you project. um, uh, I can suggest you project names, but you have to work on it. But you need feedbacks, right? Like you need feedbacks and timely review of the project. So that cannot be done, I guess, in this in the setting where there are a lot of students. If all the student agrees to do projects, we can do that. But given that understanding of the subject is the first priority, I guess getting into projects now would not be a good decision. We can definitely do it at the last, or I can share you some resources where you can find projects related to this topic and definitely work on it. uh, I guess as the course progresses you will get better idea of projects than if you choose to do a project now, because you will understand like what is covered and what is not. Okay. Okay, so is this course suitable for robotics? See, robotics is a field like which covers a lot of domains. Like robotics is if you start looking at robotics, you start with mechanics, and it starts with it will cover mechanics, it will cover electronics and electrical component also. Also computer science. In the computer science domain, there is like operating system stuff is going on in the I mean. Um, Operating system thing is going on with the robotics also, because you have to install the OS and stuff. Along with that, you also need um, along with that you also need um, along with that you also need this ML stuff where the robot is making decision and the robot is kind of taking decision and taking reinforcement learning things into account, all these things. Of course, vision course will be essential for robotics, but I would say that vision is not the only one thing that you can learn to tackle a topic like robotics. For robotics, you need to learn vision as well as associated topics that is there that is relevant for the robotics. Vision is needed, but it's not the only thing that is needed. So I guess you need to look into all those topics that I talked about. Yeah, everyone can like ask about this course itself, because it's a first session, so we can like basically discuss about what the course is about and what it will cover, and if you want to continue or not. If it is not or of your use, you like shouldn't continue. Like you can choose not to. You can choose to. live. And yes, so this is about the course. Any other questions related to the course? And trying to ask anything. Someone, Shanmati is asking something, or can go to mute, I guess. Okay. Okay. So the thing is that, yeah, what I was telling. Earlier, in this vision domain, suppose we have an image. So we try to see automatically, obviously. As a human, we can see that okay, this is a edge, and this is a straight edge, and this is a curve line here. But for machine to understand, we typically need some sort of processing ideas that can like that we can apply on a region of this image, which can tell that it has a edge. Basically, this is the idea. So it can say that it has a edge, or this has a curve line. All this sort of thing. So detect that. So there are a lot of way to. So these are basically different textures. To detect that, there are a lot of technique which is discussed before the deep learning era. Before the deep learning started, people tried to come up with different way of detecting these things, and a different way of detecting these things, and kind of learn any inference out of this. But the course is about deep learning. So so uh, some guy asked about like texture, how to like just talk about how to detect textures. So why the lecture one is there, it to show you that these are the earlier, like these are this structural and statistical techniques are the earlier way of designing this thing. But recently, after the introduction of deep learning, these methods are obviously not used. Like these are very old methods, and also these methods give very poor performance as compared to nowadays scenario. So suppose like if I talk about um, the structural features, structural in the structural feature metric. So we have this local binary operations or local binary patterns, and the second thing we have like DFT, discrete Fourier transform, and the third thing we have wavelet. So these are the part of image processing, not computer vision as such. In the image processing, what we are going to do, like we thought of image as a signal, and we tried to do all these operations on the image itself. And in the lectures, the in the lecture the professor didn't like go depth into the subject because this is not the interest of the course. So in the LPP, he mentioned that okay, given a given a pixel space, given a pixel space, so it will look into all the neighboring pixels, and it will tell that what is the LVP score that is there for a given pixel. But he didn't mention what is the use of it. Like, I mean, I can compute the LBP, the this I mean local binary patterns, but he didn't mention that what is the use of it. Like, I'm not able to like see like any use there. Like, of course, there is use which will be utilizing this technique to recognize any pattern or format in the image. But typically, these methods are very old and it is not used recently. So it's just an introduction is given to that. So these are the techniques, and we were leveraging it earlier, and we used to get the patterns using it, but this is not the case currently. One question, is it necessary to have some basic knowledge on machine learning and Python before doing this deep learning course? Yes, of course, like some a sort of machine learning experience is needed and some sort of Python knowledge is needed. But if you don't have, it's not like that you should leave this course. You can parallelly go through some resources, and like a very less amount of resources needed, and I mean, if you spend a very little time, you can start to understand this course, I guess. You don't have to go through a lot of things to go through this. Yeah, will these videos be shared for future reference? Yes, this is all these live lessons are recorded, and and it will be shared with you all. Like, I'll share the YouTube link of all these things, so you can understand it better later. And yes, so any questions regarding this? Okay, so these are, so I'll continue with your discussion. So these are older methods of doing things. So but nowadays we are not like not really looking into this. So I guess most of the students are asking, like, if they are not comfortable with machine learning or deep learning, is this course relevant to them, or like, so should they do a ML course? So just raise your hand, or like tell me in the text if I just discuss some of the key machine learning concepts and ideas that is there in this session, which is needed to kickstart this course. Someone can reply, and like somebody can like, or raise your hand, like if you agree with me. I discuss some of the key ML concepts and like give a overall idea so that you can do these courses. Hello. So I discuss some ML concepts, or like deep learning concepts, uh, that is like beginner level, so that everyone can understand and go forward with this course. Okay, so I got two yes. Okay, I'm getting yes. Okay, so how many of you like are familiar with ML? Like, have done some code or some idea that like this is the ML. 1 second. Okay, so I guess uh, familiar with Python and little bit of machine learning, some basics only. Okay, so I'll start with ML then. It will be better. I'll just okay. So if like while interacting, if so we're starting this ML in the interest of everyone that so this course need ML, and you cannot do, I guess, parallelly two courses with doing ML and things. So that's why I'll just give some introduction to ML. So so let's suppose, like, if anyone wants to like interact, even they can like unmute and interact. It will be better, like it will seems lively. So let's say I'll start with this. So if I give you a pattern, like 2 is equivalent to 4, 3 is equivalent to 6, 5 is equivalent to 10, and then I'll ask, and the 7 is equivalent to 14. So what will you say about 9? 18. So I got to answer 18. So Sarsi gave, I guess. So Sasi, how do you know it's 18? Like, I mean, um, it's very easy, right? Like you see, two is there, and four is there, and three, six is here. So it's like they're double. So what I can say is that so it's a pattern, right? Like, I mean, we are basically here looking at a pattern. So, so if I give you a bit more complex pattern, so if two is six, three is 11, five is 27, then seven is 51. Then what about nine? So here, if input is x, output is 2x, and so this function is f of x equals to 2x or y equals to 2x. Yes, I got an answer 83. Okay. So I guess, yeah, everyone else can give their answer. Yeah, I'm getting 83. Okay. Okay. So answer is 83. It's not double plus 2, so I guess it's square plus 2. So the answer is 83. It's correct. The thing is that if it is x, what I'm doing, fx is x square plus 2. Okay. So basically, so it's a pattern, right? So it's a function, and we are sort of assuming. So we're sort of guessing what the function is. So it's like guessing the function, guessing the f given x and y pair. Okay. Uh, just give me a second. Yes. Given x and y pair. Okay. So given x and y pair, we can guess the. I mean, we can guess the. What is my guess? Give me 1 second. Okay. So given x and y pair, guessing f given x and y pair. So this is the primary goal, I guess, here, like guessing f, the x y and pair. So what if I give you a more complex thing to predict, like suppose if, two is just thinking about a complex thing. Uh, is 7.38 and 3 is 20.008. 4 is similarly uh, 54.5. Nine eight. So can you tell me now what is nine? I'll wait for 1 minute. So if I'll ask, let's see, if someone can answer. If someone can answer, then it is very good. But it's like I will not wait much because it will be difficult for you to tell this pattern. Uh, so here fx is e to the power x. Okay. So guessing this is much harder than this above two. Also, if I go like if I just instead of fx, if I just change that to uh, f of x and y and write something in terms of x square, then y cube plus xy plus e to the power y plus sin y. So it will be very hard for you to like see what is going on here. Like given x and y, you cannot tell what will be the what is this function, right? So so machine learning comes. So this is where machine learning comes. What machine learning is telling that so you don't have to like sort of know what is fx. So for a so if uh, so if this pairs are given, the question is, can you guess the function? But as human, we can guess only till certain level. I think like you all gave answer till I like started till I give this two function. The once I started increasing the difficulty, I guess you guys like couldn't give. So as human, we can go till certain level of abstraction, a certain level of complexity. But what machine learning can do is that given a data pair, these data pairs, it can generate it can approximately predict this function, and it can approximately give us correct results. So this is like ml. So if I can say it in a raw language, it will be like predicting the function, or you can say approximating the function, that is by approximating the underlying function given a data set. So in anyone have doubts on this topic, like the definition that I gave right now about the definition of ML? Like, is there any doubt on that? You can ask now. Everyone got the idea? At least they guess so that I can move forward. Like, what is the idea that I'm trying to say here, or like trying to discuss here? Okay, I got one yes. Okay. So the idea is that, so I'll just reiterate what is the idea. Idea is that given a data given data pairs, can we guess the function? Yes, if it is easy. No, if it is complex. What should we do if it is complex? We will use machine learning. Okay. So then I'll come to the second part where I will discuss some terminologies. Terminology of ML. Okay. So the first terminology is features. So this here, this 2, 3, 5, all the left side thing, I call features. So first terminology is features. So what is features? So features are those things which we use for prediction. Uh, Variables used for prediction. Yes, someone is trying to ask. Hmm. Question is how to decide about a machine learning model to be applied for large number of input and output variables for a problem. So see, first thing is that, so if you have a XY pair, okay, if you have a XY pair, and here I is 1 to n, xi, ya. So if you have XY pairs, then you can always apply machine learning. But if the number is if the number is very less, like it's like around 1,000, we shouldn't like use ML. Like I guess looking at so I'll just give you an example. Okay, here, even if like after looking at three pairs, you can tell that okay, it is x equal to y equal to fx. Sorry, fx equal to 2x. But here, I guess you need a bit more. If I complicate the function a bit more, you need more data set. So, given a xy pair, you cannot really decide that is it sufficient for me to approximate this function or not. It will depend on the function you are approximating. If the function is very complex, so you need lot of data, because also as a human, if it is like 2 to 4, 3 to 6, after this two data set only, I can tell that this is doubling. But here I need at least 3, 4. Like if you're smart enough, you can do it too. That is fine. But if you're not smart enough, if you're me, then you need 4, right? So it will depend on the complexity of the function rather than what problems you are solving. So I guess complexity of the function is the key. Okay, I'll just erase this. Okay. The next terminology is the level. Okay, the variable least of prediction is the level is the true class of true class of the input. True class or like I can say, true output. True output. It's a true output. So so for 2, the true output is 4. For 3, the output is 6. 5, the output is 10. So it's kind of like the actual value of the level. And then third thing that we define is the data set. Data set is the collection of features and levels. So data set is the collection of feature and level. So if features, so yeah, features, we generally denote it as X or capital X. I will use capital X because it is convenient. Capital X. And so what is the dimension of this X? So this dimension can be one dimensional. So to denote one dimension, I will tell that r to the power n, r to the power 1 is like r and the real number of one dimension, or it can be n dimensional. Anything 2, 3, 4, any number of x can be here. So if for this it will be only x. Here it will be like x1, x2 up to xn. Okay, and y is one dimensional. It's only y. Okay, and if I collect all these things, so the collection of all the things xi, yi, I equals to 1 to n. This is the data set. Did you get it? So anything, so okay, so this is the data set. Then the next terminology I'll discuss. Uh, Next terminology is uh, target function. It is denoted as f, and it is a parameter of fx, and we need to like activate this function given given x and y pair. Okay, so is everyone clear like what we're trying to do here? Hello. Yes. Okay, so this is the like thing. So to approximate this function, so there are a lot of different techniques that is there to approximate this function, or we can say to predict this x given x. So you'll be given xy pairs initially, and at the end you will be for a given x for which a y is not known. I'll like it will give x, and with the learned function I will predict the y. So talking in the like normal way, I can say that suppose okay, so there are two tasks of machine learning. The primary task. So there are a lot of tasks, but two tasks is like one is classification, and second one is regression. Okay. In the classification, what to do is that given an input, we need to classify it to certain classes, class 1, class 2, or class k. In the regression, given data, we need to predict one value. Okay. So here the prediction will be numeric. Here it will be r to the power k, because we need a k dimensional vector. So where if it is belong to class 1, it will be 1, everyone else will be 0. If it belongs to class 3, I guess 3, then 1, 2, 3 will be 1, others will be 0. So it's a way of representing the sample. So these are two basic tasks of classification and regression. So I'll give one example. These two tasks. Okay, repeat. Okay, so I'll just give you like example. Coming to regression. Okay. In the regression, so suppose say this is an area. Okay. And here is a hospital. Here is a school. Okay. And here is a temple. Okay. And here is a temple or masjid, whatever. And keep it here. Some devotional thing is here. So suppose this is the entire area, and you want to sell. So here are like plots out there. So these are the plots that is there. They're like open for sale, and you want to buy. Okay, so this is plot number 1, 2, 3, K, anything. Okay, so so you want to given so you want to sell these plots and you want to price this accordingly. So you don't want to like price every plot as same. You just so to price this, so there are some plots which have already filled earlier. Okay, so these are the plots already filled, already like people are staying there, have built their home. So what you did is that you just went to a plot number 1. You try to collect some features. Different color. Uh, So what we are collecting is that what is the distance to medical, what is the distance to school, what is the distance to temple or masjid, temple or masjid. Okay. So what you got is that so for plot number one, distance to medical is, let's say, like 1 unit. I'll just tell in unit. Like for school, it's like 1, 2, 3, 4, 5, 5 unit, and for temple, it's like 1, 2 unit. Okay. So this is your x1, this is your x2, and this is your x3, right? Then you went to the plot number two. Similarly, the distance to the school is, sorry, hospital is 2, but here it is 4, and here it is 3. For plot number 3, it's like 1, 2, 3. Distance to school is 3, also 3. It is this 1, 2, 3, and church is 1, 2, 3, 4, like that. So like that you collected. For plot number 7, uh, it's like distance 1, 2, 3, 4, 5, 6. To school is 4, and church is 7. Okay. So let's say like these plots are like captured through 3 and 7. These plots are captured too, and you have the audacity to go and ask there, like, what is the price? Okay, what is the price that is there? That is like of your plot. Okay, so you went there and you sort of asked them about what is the price that they are like selling, like got their plots, and also you note all these distances. And if I note down y here, okay, this x. So if I note down y here, and y is the price they paid for that plot, and suppose for this you paid the price of say uh, 10 lakhs. Here you paid let's say 9. Okay, 9 lakhs. Here you paid let's say 8 lakhs. Here you pay 10, 6 lakhs or something. So we can see that, like, if the distance from your home to hospital is increasing, the price is decreasing, right? I mean, so okay, so you can now what you can do, you can, so we can say that the price of the a place somehow dependent on the function of x1, x2, and x3. Somehow or the other, price of the house or the land somehow dependent upon these 3 factors, distance to all these things. And what you did is that, but you don't know this f, right? So you don't know how they're related, but it is related. You know that it is related, but you don't know how. So what you can do is that you take a ML algorithm. Okay, you give this xy pairs. So you tell that, like, so these are my xy pairs. So you algorithm take this, and what you give me in the return, you give me what is this f approximately, nearly equal to. What does this f? So what this ML algorithm will do, like, it will look into all these all uh, all these pairs, and it will find the pattern that is associated with all this data, and it will give with the final f what is that is there. So this type of problem, like, so here the if I give someone is on mute, I guess. Subrato Janna is unmute. If you want to speak something, you can unmute or can mute yourself. Okay. Okay. So if it is like Okay, so if it is so here, given if I give the algorithm a new point, like where the distance to the school is 5, distance to the uh, hospital is 5, school is say 4, school is say 4, and temple is 3. It will give me the corresponding prediction, like the price would be, let's say, 8 or something. So this type of problem, we're basically predicting a value rather than predicting what class it belongs. So these type of problem are the regression problem. And what we can do is that better way to visualize is that, like, suppose you are given some data points, like if the distance is to school is 5, the price is this. If the distance is this, price is this price, this distance. Let's say combined distance, or like distance school plus hospital plus the devotional space, and you add all these things, like you get all these things, all these points, like if the distance is this, the price is this, distance is this, price is this, and at the end you'll be given, like, if the distance is this, what will be the price. And what we do typically is that after learning the ML system, it will be able to say that, okay, if the distance is this, price will be this one. So there are different methods to uh, see, like, predict all these things, but I will discuss the methods later. But is the idea clear? Like, what is this regression is saying? Like, what is the main idea behind the regression? So I'll say that, like, given a x, it will kind of predicting the y, and where the y is a real number and it is stating some value uh, that is associated with the all those inputs, and how it is computing. We don't care now, but I'll discuss the technique later. Is it clear? You can say in the chat. If it is not clear, I can go again. But okay, Srikant said it is clear. Everyone else, like, if it is clear, like, I can go again, like, I can go very depth. Clear. Ram is clear. Okay. Good responses. Clear. So I guess everyone is clear now. So I'll go to the second thing, that is classification. Classification is very easy. Like, I don't have to give all these examples, much examples in the classification. In the classification, what it is that given a image, you just have to classify that into something. So classifying is that, like, so you need to define, like, what class that is allowed to be classified. Suppose give me 1 minute. Suppose you have images of cats and dogs. Okay. Everyone gives example of cats and dogs. Let's say crow and doves. Okay. No, cat and dogs. It will be easier to draw. So here is a cat. Okay. You have like 100 images of cat, and here, let's say, let's just call this as a dog. Okay, and you have 100 images. In the label, it can either be a cat or it can either be a dog. Okay. So what you are doing is that, given these hundreds of images, so here, if I make all these XY pairs, what it will be? Image of cat, Y will be cat. Another image of cat. Not the same, not the same image. It will be different cat, different variant. The label will be cat. Okay. Then there will be image of dog. The label will be dog. Okay. So if the pairs is like this, like the x's are like images or text or data, but the y's are like a, a categorical entity. Categorical entity means it should be either of. So here the house price that I mentioned earlier. So the house price can be anything. Like it's not like that. It should be in the range of 8 to 10, but it can be anything in that range. It's not like that. It should be only 8 to 10, but it can be anything like 10, or it can be like 8.37 kind of lakh. But here, so here there is no bound. It can be anything. But here you have this bound there. Like it can be either cat or dog. If I represent C as 0 and dog as 1, I can say it can either 0 or 1, not anything uh, away from it. So if the is the y variable that is there is categorical, like it is 0 or 1, so then it is a classification problem. It's a classification problem. Okay. So is everyone clear about what is a classification problem? Everyone should respond, I guess. If it is not clear, I can go deeper. Okay. I'm sure it's clear. Everyone else, is it clear? Like, should I go again, or should I proceed? Okay, clear. So classification and regression is done. So next we can go to, so yes, in this deep learning for visual computing course, we will be majorly looking into classification, not regression, and some other task that is there. Should I go a bit slow, or is the speed is fine, or should I go a bit faster? No, not fine. Like I asked, like so the speed be slow, or this should be fine, or okay, this is fine. Faster. Okay. Classification regression is done. We will talk about. So we'll start talking about in the context of images. Since we are like looking into images, so we'll be talking about images. So what is classification in a normal context? So in the normal context, so classification in the normal context for tabular data. Okay. So we'll first come to the our house problem, where we have all this hospital, or second one was school, third one was temple. Okay. So we'll come to this. So if three things are given, x1, x2, and x3, we are predicting what will be the y. So I'll make it little twist here. So instead of predicting the house price, I will make some brackets in the house, like in the price. suppose one bracket will be 0 to 5 lakh. One bracket will be 6 to 10 lakh. One bracket is 10 to 15. Last one is 15 plus lakh. So given x1, x1, x2, and x3, I need to classify it into one of these four buckets. Okay. So now can anyone tell, like, is it a classification task or is it a regression task? If I change, like, instead of directly predicting y, I'm just predicting which bucket it belongs, not that what is the price of y. Now, like, can someone tell, like, what is the task here? Like, is it a classification task or is it a regression task? Anna is saying it's not classification. Okay, so I guess so I'll just ask the question again. I guess I miscommunicated the question. So when the so what I said in the classification problem, when the y is discrete or y is categorical, it is a classification task. So here my y can either belong to this, or belong to this, or belong to this, or belong to this. So is it possible that a house can be in the range of 6 to 10 lakhs and also 10 to 15 lakhs? No, right? At a time, only one can be possible out of this four. So what I'm doing is that, so given 6, 5, 9, I am classifying it as, okay, this should be 6 to 10 lakhs. Given 3, 2, 1, it should be 10 to 10 lakhs. So here, if I assign this 0, if I assign this 1, if I assign this 2, and assign this 3, I can say that this is class 1 and this is class 2. So it's basically classification task. So I guess you guys gave wrong answer. Regression task. It's a classification task. So if I have to, like, predict the price, like it's a 7 lakh or like 8 lakh, it's a number is involving. It's a regression task. If I'm, like, classifying all these things into a bucket, so then in this case it is a classification task. Okay. Okay. I guess everyone is clear on this. Okay. So it's a classification task. So we are, like, kind of putting it into different classes. So in the context of images, classification, in the context of images, what I can say, given a image, I need to classify it to some class. So here what happened is that while saying that, okay, this belongs to 6 to 10 lakhs category, or this belongs to 10 to 15 lakhs category, what we did is that we looked into all these things. Okay, the distance is this, the distance to school is this, and hospital is this, and these are the caveat here is that here the number of feature is very high, like the feature very low. The feature is number of feature is only 3, x1, x2, and x3. So we have features here. So for any ML class, I told that, like, you need features, right? if there is no feature, how can you learn this mapping from X to Y? So you need features actually, and you need all these X's in the left hand side and Y's also, so that you can calculate the function F using the algorithm. But in the image, what is these features? Can anyone guess? Like, so in this classification task or in the house prediction task, your features are distance to all these things. Okay, and it is a three-dimensional feature. Like three features are there: x1, x2, and x3. But given a image, so here in the classification task, you told me that okay, if cat is given, it should be here the cat is feature, the cat is x, and y is the class cat. But what is these features here? Like, what can you tell about these features? I mean, it should be something like something like x1, x2 up to xn. You agree, right? It's a ML task. So what is this x1 here? So my question is, what is this x1, or basically, what is this xi here in an image? I'm getting one answer. Okay, intensity, two answer: intensity, brightness, safe size, etc. Second answer is RGB percentages. Good. Any more answers I can get? There are like, I guess, 7 or 10 people are there in this call. 8 people are there. Everyone trying to participate and tell. Like, if you like have any questions, you can ask me. I can clarify any of your doubts. If you like don't participate, then there is no point in conducting these sessions. Uh, uh, of course, I will respond to all the people who are interacting, but I will. If you are like not in a good environment, then it is fine. But you have like access to all these things, then I would encourage you to participate in the discussions, so that um, you can clarify these concepts, because these concepts are very crucial and very useful in today's scenario. If you understand all these things, you'll get like a very good opportunities and very good um, promotions in your respective institution or organization. I would encourage everyone to like participate at least. Uh, and I recently found. Okay, okay. So Sumit said intensity, brightness, safe size, and Ram said RG percentage. So before going on to the answer, I'll tell like how a image look like. So if you this is the image, like this. My screen is also image. So if you deeply understand the image, so it consists of three layers. One is red, okay, red layer. The second one is blue, like green. Okay, blue. The third one is blue. Okay. And this is called RGB, red, green, blue. Red, green, blue of images. This is the RGB representation of the image. Another type of representation of the image is there, like that is a three-layer representation, like the three-layer interpretation of the same image. It is called hue, saturation, and value. So it is called HSV. You must have seen these things like hue, saturation, all these things while editing your image or photo in the phone or something. There are two representations, but primarily only the first one is considered. So what happens is that here you have very tiny particles called pixels. Here will be red pixel, here will be green pixel, and here will be blue pixel. Okay. But it won't be completely red, completely green, or completely blue. So it will be some proportion of it. So the any pixel, okay, so it is the pixel. its value can range between 0 to 256. Okay. So for red also it will be same, 0 to 256. Green will also be same, 0 to 256. Blue will also 0 to 256. Okay. So basically, uh, any image in this world or any color that you pick, suppose I pick this color. Okay. So if you pick this color can be represented as a sum of red, green, blue. Okay. So this red value can be suppose 89. It should be 0 to 256. It can be 71. It can be 193. So any arbitrary combination of any combination, like all the colors of the world can be represented using this. So the number of colors we can have in this world is 89 cross, sorry, not 89, 256 cross 256 cross 256. This is the possible number of colors that is there. Uh, According to the this thing, like we can have all this many number of colors. So I'll just okay, I'll just tell how to color to RGB. Um, RGB. Nothing. Okay, so just look into this. So suppose I want to choose this color. Okay, any color. Okay, and I can see that this color has red value of 110, blue value of 156, and green value of 250. Okay, so this is like some different. This is some different. This is some different. So every value is there, but everything will be like between 0 to 256. So this is the representation of the image. Okay, so any color. So any color in this world can be represented using these three colors. So what about pixels? So you must be like familiar with all these terms like okay, let me, what about pixels? So you must have like heard about 720p or 1080p. So what they are saying is that, so if an image is here, basically this length is 720. So there are 720 number of small pixels in this direction, and this direction accordingly to the according to the aspect ratio, these will be like the number of pixels in this direction. For 1080, similarly, you will have 1080 pixels, and yeah, so and value is not like 0 to 255. Yes, 0 to 255. Sorry, it should be 0 to 255. I'll clarify all this thing. Give me a second. 255. It's not 256. 256. 6. Okay. So one question. So can someone tell if the number of pixel is so everyone must be using laptop or phone of full HD or 4K screen. So can there someone tell like we all don't always stream 4K or don't always stream full HD. If it is 720 pixel, how can like a full HD screen is able to capture it? Like or you can say if it is 1,000 pixel is there, how come a 4K screen is able to show that? Because if the screen is like 4K, so then it is capable of accommodating 4,000 pixels here in this length. But if you have a image of 1,000, so it should be like this, right? 1,080 pixels. So your image should be like showed in this portion of the screen. Why it is like showing in the entire screen instead of showing it in the corner or showing it in this half of the screen? Can someone answer like why this is happening? I'll tell how this is happening, but also the other way around. Like if you have a 1,080 screen, if you stream 4K videos, it will still be able to play. But ideally, it should be like this should be the actual uh, uh, image size, and you will be only able to see half of the what is showing in the picture. So, anyone like guess what could be the like trick here to show all these things? Yes. So okay, so I'll tell. It depends on the area of illumination. No, it's a basic thing. So what I'll tell them. Suppose so this is the image and it has pixels in the horizontal direction and the vertical direction. Okay. So what will happen is that if the screen is 2K and your image is 1K, screen is 2K and image is 1K, what it will do is that it will take this line of pixel, it will make a copy of it and paste it here. So your entire image now will be original copied, original copied, original copied. So it will like this. Since pixel is very small, so if you have a like fish that is looking like this in the image, and if you just copy this column and paste it here again, so it won't make any difference. So the fish will be intact, and you'll get a clear image out of it. Similarly, if in this case, this given, so this line of pixel is left and this will be deleted, and this will be left and this will be deleted, and this will be deleted. So in this way, like you're just removing a line of pixel and you're able to adjust it. Okay, coming back to our like main discussion, why so sort of this so how to like what is this x, what is this x1 here? So this x1 is, okay, I'll just uh, insert emoji. Okay, so coming back to the discussion. So here the x1 is x1 is 1 pixel value p1. X2 will be then again pixel value p11 I will say and p12. Because our image is red, green, and blue, and this is p1 11, p12, This is P21, P22. Similarly, in the blue, it is P31, P32, and so on. Here also, and so on. And here also, and so on. So suppose like, so I'm just sequentially taking the pixels P11 and took P12, and my previous X2, X3 similarly will be P13, and after some iterations like XK will be, let's say, P21, XK plus 1 will be P22, and like this. And if you see, the end one will be X, N will be P, and this last picture, let's say K, 3K. Okay. The idea is that all these pixels here are my features. So there is no distance to the school, temple, or masjid, or all these things. Here the pixels are my features, and by looking at the pixels, we can say that so these are given. These are the features. Can we classify this as a cat or a dog? So how do you classify a cat or dog? As human, what we do? So what we do is that we look at a cat and we see that okay, so the cat has furs. Okay, so I'll just draw here. So this is a cat, and this is body. So what will look into a cat when we classify a cat as that? We see that okay, so this has like this. Uh, okay, we say that okay, this cat has this. So that, okay, so we say that cat has this ears and these hairs that is from coming from his mouth, and all these furs are coming in this direction. Eyes is like this. Then it is a cat, right? So okay, so before coming to the cat analogy, so can everyone say that like, do they understand like what I tried to tell here? Here, pixel are the features. So features are the pixels. Like we look into pixel and say if it is a cat or dog. So if everyone like agreeing with me, or is there any some sort of confusion that is going on? Okay. Everyone is clear. Like pixel is the feature. So what do we look into while classifying a cat? Like as humans, we look into hairs and the ear or the all these things. And can someone tell like what do we look into when we um, think something is a dog? So what are the characteristics that you look into when we see a dog? Or in general you can say when we look into some other objects, say bottle or some desk or something, what do we look into and say that okay, these are the things is present, and so that's why this image is of a bottle or a dog. It was off, I guess. Yeah. What do you look into before telling if it belong to a something or object? Basically texture, right? So for a cat, the texture of the skin of cat is different than the texture of the dog. Also, the ear, the nose, the eyes, and all these things matter, right? So the eyes, these textures, the type of ears, these hairs, all these things will constitute that, okay, this is a cat, right? So what if, so how to tell that, how to tell a machine that these are the things you look at and tell. Okay, so if I like intuitively write, what will be my X1? It will like fur type, or X2 will be ear shape. Okay, X3 will be eye. Okay, so these are the like features: ear shape, eye, and fur type. So can we assign a value to this? No, right? So I cannot look into eye and say, okay, I this value of this eye is 10, right? We cannot do that. Or we cannot look into the ear safe and tell that, okay, the ear safe value is this. Unlike that we're doing with the house prices, like if the price of the distance is this, we can say, okay, the value is 4. But here we cannot do that, right? So we cannot do that. So that's why what we're doing is that we're saying that, okay, suppose eye is here. What I can do is that I can look into the pixels that is there in the eye. So let's say these pixels are there. And let's say I add the red, green, and blue channels. And after adding, my values can go from 0 to 255 into 3, right? So I can just write those values: V1, V2, V3, V4, up to V9, right? So how to quantify AI? Like how to quantify that? Okay, this is the eye, and this belongs to the cat. So internally in our head, we must be doing this, but as humans, we do not think about it. Like what is the quantity of this eye, or what is the quantity of this um, fur? So what we can say is that we can look into the pixels and say that, okay, these are the pixels that is there. And since this pixel is sort of have value all these things, so I can say that, okay, this eyes has value all these things. Let's put these values as the features for eye, and let's put this value as feature for myself. Okay, so this is like raw. This is like raw thing, raw pixel value. But can we infer anything more complex out of this? Like, can we go a bit deeper other than this? The answer is yes. So we can look for edges. We can say that in a cat, the edges will be different than a dog. So what all these things indicates, like this ear type, ear shape, fur type. So basically, it's defining some texture. So in an image, what is important? How the texture is varying throughout the image. Okay, if we capture that variance of texture across the image, or if we capture that thing, thing around the image, we can say that, okay, the pattern of texture in this image is this, and that image is that. So that's why this is the cat and this is the dog, right? So in the feature, in the machine learning problem, the feature can be pixels, which is the raw thing, but we can also, from the pixels, we can derive some of the texture values, or quantify some of the textures that is there, and treat them as a feature instead of doing this. Okay. Okay. Any questions? Like any, like, do you get the analogy why we're like concerned with the textures and pixels as such, to classify any image to something else, or in general process any image? Why we're like, why texture is important. Could anyone reply like, did they get the knowledge of tech? Why texture is important? Why it is uh, essential to go into and look into textures that is there in the image? Anyone? You can interact. No one like. Do you want to repeat this? I can repeat this if you want. Question: what is the difference between conventional image processing and machine learning technique for image recognition? Okay. Okay, so I'll take this question. So conventional image processing. So you just have to look into the term. You'll be able to differentiate between them. So conventional image processing, it's just processing the image. So if you process one image, you will get edges. Suppose what are the edges are there? I'll just show you one example. My screen is visual, right? Uh, okay. So this is like edge detection. Given an image, it is showing what edges are there. So my screen is visual, right? So for this image, what are the edges? So for this image, what are the edges present in this image? So image processing is sort of uh, uh, taking the image and processing it and getting certain things out of it, edges or curves, or you can say blurriness or anything. So that image processing. But are you getting anything intelligent out of it? No, right? I mean, so here is edges. Then what? I mean, it's not anything of use, right? If someone is showing you a photo of someone, so if some face recognition system is deployed in in some city, it should be able to classify that, okay, this man is a culprit or something. It's not like that. I'll extract the edge and look into it. So then what is the difference between image processing and image recognition? In the image recognition, we are getting intelligence, but in the image processing, it is not present. We're just processing the image and getting a output as a image. But in the image recognition, we're processing the image. We're like taking the input image as the input, and we're classifying it to something else. Like either we are recognizing the person in the image, or we are recognize the object in the image, like if it is a fruit, or if it is a bottle, or if it is a watch or something. But that is not present in the image, the conventional image processing, where we just look into image and we just uh, find certain patterns or textures out of it. So how these are related? Like I'll tell how this image processing is related. So in the what you can do, you can take the image and you take the pixel values, you feed into a ML algorithm, okay, and it will give you a class, okay. It will tell if it is a cat or dog, if it is a person or anything, okay. But instead of feeding these pixels directly, what you can do, we can take a image, you can process it, okay. You can get the image with edge, or you can get the image with something else. So instead of passing directly the image, you can pass the processed version to the ML algorithm, okay. And here, since it is processed, it will discard all the things that is not necessary for this ML algorithm, and here you will get a class. And the accuracy that you will get here will be better than here, because here you're just processing raw pixel. Here you're processing with context or something. So here, like for the cat, you might like looking at just the pixel value might not be that useful. But if you see some curves or like the year size, you can say that okay, this year definitely belong to a cat, and and the ML algorithm will be able to, like, looking at those patterns, it will be easier for the algorithm to predict that okay, this is the underlying pattern that is there, and you should always I mean, I can tell that this is a cat, not a dog, sort of thing. So these are the classification classes, dog and cats and stuff. So it's clear, like why texture and feature and image processing is important in the for the visual computing or image recognition. Like they are not like state of the art. We don't use that nowadays for computer vision at least. But so there, if that step is present before ML classification, then it is better for us. Okay. So is there any other doubts? Then you can ask. I guess time is like ending. So time till 8. If anyone can ask anything else, it will be better. Give me 1 minute.
Hello, good evening, sir.
Yes. Hello. Just
Hello.
yes.
Good evening, sir. Sir, how to
Yes.
decide how many layers we required in deep learning?
Okay. Okay. So so we haven't started deep learning yet, but it might not be relevant to all the students. But I'll
Okay.
just tell it now. So what happens in deep learning is that you give a image and you pass that image to different layers of deep learning, and at the end you will get the output. The trick with layers is that you have to experiment. It's not fixed. Like it's not fixed that this number of layers will work and this number of layers will not work. But the analogy is that the deeper you go, the more complex function that you can model. Suppose it's not a classification of cat and dogs, but it's a classification of 10 different classes, like cat, dog, frog, and car, ship, aeroplane. So here the task is a bit complex than just to classify a dog and cat, right? So if a dog and cat, if the number of layer you are requiring is 5, then you can go for 10 for 10 different classes, I would say. Also, second thing is that if the image size is larger, like if it is 32 cross 32 image, then it's easier to train. So then you can go for just 5 layers. But if the image size is 100 cross 100 or like 300 cross 300, and then the number of pixels will be more, right? So 300 cross 300 means like the length is 300 pixel and breadth is 300 pixel, and of course the number of channels, the image channels, red, green, and blue, it will be 3. So it will like 300 plus 300 plus 3, and the number of pixel is way more than 32 plus 32. Then the computation will be larger on the function that you will be learning here. The f will also be complex. So at the end, so you need to learn that function, and so since it is a complex function, you need to go for very deeper network, say 15 or 20, rather than 5%. Does that answer your question?
But is there, yes, sir? Thank you, sir. But is there any relation between the number of classes and the number of inputs to the number of layers should be present in the deep learning?
Yeah, so you're looking for like given a number, given the input size and given the class, given the number of
Yeah,
classes,
yeah.
is there a
If
way to compute the number of layers needed? That is for
yes,
the
sir. Yes, sir. Yes, yes, sir.
no. So there is no such formula as such as of now, I would say. So it is
Okay,
not
sir.
certain, right? You don't know what we are learning. So that's why we cannot guess that okay, this is the number of layers. So you can
Oh,
always experiment, or you can just look into the knowledge that was gained earlier, like what people have used for this similar kind of task. You can just start from there and experiment your way to the till the optimal number of layers in a deep neural network. That is there. Yes.
okay, sir. Okay, sir. Thank you, sir.
So I was talking about like textures. So is everyone clear like why textures are an important criteria while looking into classifying images? Because we could have just gone with pixels, right? So if I could have just passed pixels to the ML algorithm, but instead of pixel, I'm looking to textures and trying to say that okay, textures are also some good way of representing the same image and kind of classifying. It also helps in classifying those images into cats or dog or any class. So everyone is clear on that. That thing texture.
Sir, one small doubt, sir.
Yes, yes. Like I'm just waiting for everyone to say that they're clear about this texture, but yeah, go ahead.
Sir,
Everyone can
actually,
respond in the chat.
sir,
Yes,
actually, you said no when we are doing machine, deep learning, it will extract the edges.
yes.
But how it can extract the textures? Textures means how smooth it is the area surface.
No, no, no. Texture, like texture is something like you can say generally. What's the texture of butter? Like it's smooth, right? So what's the texture of a rug that is there in your home? It's very harsh, right? So textures, what I meant by texture, I meant that like edges or corners or smoothness or blurriness. So everything like combinedly, I just
Okay, okay.
named it as textures, or you can say the different detectors. I can say edge detector or like smoothness detector, sharpener. So all these are different features. You
Okay,
can
sir.
say,
Okay, sir.
yeah. I
Okay.
mean, different way of redefining the same image. So, edge detection is there, and corner detection is there. So, so yeah, so I'll just close it with a remark like, so since texture is important, the week one, lecture one is dedicated to textures. So how to, what are the type of textures and all. But the twist is that we won't be focusing on that much. Like someone asked about like age level textures or something at at the start of the class. But we shouldn't focus on that. Like you just did your assignment one, so that is done. Like first five questions are from the lecture one, then that is done. It is fine. From the second lecture onwards, the professor started talking about. I guess in the second lecture he talked about the neural network, right? The someone can like remind me. Uh, Okay, so in the lecture four, so in there is a hands-on session. You can just go into the hands-on session and take the notebooks and run yourself to find the textures out of this. From the lecture four, he talked about neural networks for visual computing, and I will not like so here this F will be represented as a neural network. Okay, so neural network is something that will be able to approximate the function or approximate the relation between the cat and its actual level cat, or you can say approximate the relation between this house prices like these distances and house prices. It's kind of neural network is a way to approximate this function. You can say is a way to find relation between this input and output pairs. So in the next class, we'll look into the neural network. So I will ask, like, suggest everyone to go through the lecture from the week 1, the lecture 4, and week 2, all the lectures. So we'll be discussing the half of week 1 and all the lectures of week 2. So I will not be like discussing everything the way I did this class. I'll be just like going on like solving the doubts. When the doubts are done, then I'll go to the previous year question, assignment question that is there. Then I'll start to solving there. So if you are not comfortable with the question I am solving, then you should like stop me and say like I need the background on this. Then I can go deeper on that background. So I guess in the week 1 there is one lecture dedicated to neural network. In the week 2 there is 4 lectures. 5 lectures are there. So you should cover week 1 and week 2 by next week, and the next week we will discuss the week 1 and week 2 combinedly, and we can definitely complete. I mean, if I if I start like discussing everything in the weekend, it will be very lengthy. So I'll just I suggest that everyone should go to through the lectures and get the key ideas. If still you get any doubt, I can just clarify that part. I guess I have given enough background to proceed with the lecture, uh, 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 and I guess you can easily understand that. If you still don't understand, I will clarify it, no doubt. Then I will solve the questions that is related to lecture 4 of week 1 and lecture uh, 6, 7, 8, and 9, 10 of week 2. Okay, I guess the deep neural network we can spend 1 or 2 weeks more. Then you can go to the thing like uh, um, going into the images and how it is represented. So the representation of image is done. I covered today. How image is like classified or all these things. We can also carry out hands-on. So Srikanth is asking like mechanical background student can do this course. Yes, yes, of course. Everyone can do this course. It's not like that the background that you have. You just need a bit of math knowledge. I guess everyone must have. And uh, uh, and you also need some programming background. Also cover on wavelet next time. Okay, wavelet like that the what I said like I can go in depth on wavelet and all these things of lecture 1, or lecture 2, I guess that is lecture 2. But there is no point in going depth in this lecture 2, because you like in deep learning you don't need wavelet thing. You can just without the wavelet everything can be done. So if you still want, I can go depth on the wavelet next class. But I would suggest that you don't like focus on that thing much, because it's a deep learning for visual computing, not only visual computing. So you should focus on deep learning, and it will be better for you. And so we'll spend next week and next week discussing what are the ML techniques that is there, like foundation of deep learning, and what is layers and all these things. After that part is done, we can go to the image recognition thing and models. But let me know like if I like continue explaining the things in this pace. Like it is a very slow pace, I guess everyone must be getting it. This pace and like doing diagrams and talking in the terms of x and y and shedding things, or should I go a bit programming? Like should I open up a code and start coding things up? Like so this is the thing, and this would be the thing. So everything, like anything you want, we can go, but we can start with the programming. I guess in the lecture 4 or something or 5, the program is done for neural network. So you should definitely check that out. The lecture 5, I guess, lab classification with perception model. You can check that out in the week 1. Then of course, like I can when I go to the neural network, I can go like do some programming as well if everyone says. Okay, I guess the time is up. It's 8 now. But yes, sir, there also need to be programming code side. Actually, the lecture covers programming. So you should do programming side by like it's a good thing for you. But if you want me to do code, I will try to cover what is not covered in the live, like the recorded lectures. And if something you can tell me to cover, I can cover that. If somewhere you're stuck, you can tell me. I can cover that. Okay. Anything else? Because we can end the meeting here. I'll share this note with you all, and I'll share this recording as well for everyone like who have joined and want to refer it again, and also people who are wish to are wishing to watch this recorded lecture after the class and stuff. If they have some other commitments as well, like code import libraries and functions for deployment. Okay, we'll cover all those things. Okay. So you should go through the lectures and see what is there and what is not there. You can just ask what is this and just try to explain what these things are. I'll just go on and explain. I guess demand is less, like not more people are interacting. So whatever you tell, so we'll do that. The class. Okay. So okay, bye bye. I guess. Happy weekend. We'll meet next Friday at 6.